as it approaches Earth, with December 19th marking the date of closest contact. We'll have an excellent opportunity to gather the best data using numerous telescopes on the planet, including the Hubble and Webb Space Telescopes. 3 Atlas reached its nearest point to Earth today, December 19th, at 1 a.m. EST, signifying a remarkable moment in cosmic history. This rare encounter with an interstellar object has left people around the globe in wonder, stirring feelings of both astonishment and unease regarding what resides beyond our home planet. Having traveled for millions of years through the immense void of interstellar space, this object is now just 164 million kilometers away, a notable distance that has captivated both scientists and the general public. For those who have tracked its path since its initial discovery, the importance of this moment is immense. It represents not merely a celestial body passing through our vicinity, but a messenger from a distant star system, offering insights into the enigmas of the universe that extend beyond our own. The remarkable close approach of 3 Atlas was widely awaited by both seasoned astronomers and enthusiastic amateurs. To witness this extraordinary event, the Virtual Telescope Project provided a live stream enabling viewers from across the globe to observe the object as it made its closest pass. Furthermore, the Skive offered real-time tracking tools that illustrated the movement of 3 Atlas across the night sky. Independent astronomers, like those from Ray's Astrophotography, added to the professional efforts, sharing not just this occurrence but also earlier significant findings about 3 Atlas, when prominent organizations like NASA hesitated to release much information regarding the object. Ray's Astrophotography stepped in, providing consistent updates to the public. His timely observations became a reliable source of information for many astronomy enthusiasts. And as the moment of 3 Atlas's closest approach neared, his live streams became a primary destination for those keen to witness the event live. The anticipation surrounding 3 Atlas's approach stems from the fact that this interstellar body has proven to be remarkably unique. Unlike any previously discovered object, it has had scientists baffled at every turn, with its unusual behavior challenging expectations. From the outset of its discovery, the object has captured the fascination of astronomers and space aficionados, igniting intrigue and excitement. Among the leading experts analyzing these anomalies is Avi Loeb, a Harvard astrophysicist, whose research has played a significant role in illuminating the peculiar characteristics of 3 Atlas. Numerous puzzling anomalies characterize 3 Atlas, intensifying the sense that this object is distinctly different from anything previously encountered in our solar system. One baffling aspect is its gravitational deflection as it neared the Sun. Instead of the expected deflection due to the Sun's gravity, the object altered its path by an astonishing 16.4, raising questions about the forces influencing it. Could there be factors beyond the Sun's gravitational pull that are affecting its trajectory? Adding to the fascination is the sunward jet that 3 Atlas sustained throughout its voyage. In contrast to most comets that expel materials more diffusely, 3 Atlas emitted a highly focused jet directed straight toward the Sun. This narrowly defined jet provokes serious inquiries about how the object sustains such a concentrated outflow, especially after being deflected by the Sun's gravitational pull. What accounts for the jet's narrow definition? How does the object maintain this alignment following such significant deflection? The opening angle of the jet contributes yet another layer of intrigue. It measures 8, precisely half of the deflection angle, an unusual correlation that diverges from typical comet behavior. Most space objects do not exhibit such precise relationships, rendering this characteristic one of the more perplexing aspects of 3 Atlas. Despite the deflection incurred from the Sun, the rotation axis of 3 Atlas has remained almost perfectly oriented in the sunward direction. This near-perfect alignment, even after such a considerable deflection, is statistically unlikely. Typically, objects passing near massive gravities like the Sun experience some degree of misalignment. Yet, 3 Atlas has defied these expectations, achieving consistent alignment throughout its course. Also noteworthy is 3 Atlas's outgassing behavior. As the object approached the Sun, it began releasing gas and dust in a manner that was notably erratic and uneven. Diverging from the typical predictable outgassing seen in comets, the bursts from 3 Atlas seem influenced by something more intricate, hinting at potential internal structure or composition that remains cryptic to us. Perhaps one of the most striking features of 3 Atlas is the absence of visible tail structures. While most comets generate long, recognizable tails comprised of gas and dust, the tail of 3 Atlas lacked clear definition and typical structure. This absence hints that the object might contain materials that do not sublime at the rates common among ordinary comets, or it may exhibit surface behavior unlike anything observed thus far. Compounding this observation, the dust clouds expelled by 3 Atlas behave unpredictably. Unlike the systematic patterns of dust ejected by other comets, the dust clouds from 3 Atlas demonstrate erratic movements, This irregularity raises the possibility that influences beyond solar radiation are at play, rendering their behavior unlike that of any previously documented comets or interstellar bodies. The dynamics of speed and acceleration also pose questions. 3 Atlas's journey through the solar system appears to be affected by aspects beyond mere gravitational forces. Its acceleration and speed imply that unaccounted forces, like dark matter or enigmatic energetic phenomena, could be contributing to its motion. This peculiar acceleration leaves researchers pondering whether 3 Atlas interacts with some unidentified force that is not yet comprehensively understood, adding, 2. The enigma is the unpredictable path of 3 Atlas, which has shifted in ways that confound predictions, complicating accurate modeling of its motion. This erratic trajectory invites speculation that additional forces are yet to be discovered. Celestial entities may be influencing its movement. The object's orbital mechanics also provoke inquiries. Unlike standard comets or asteroids, the orbit of 3 Atlas has shown signs of being shaped by extra factors. Some scientists theorize that unseen gravitational influences or an undiscovered celestial body may be impacting its trajectory in ways that remain unexplained. Another anomaly lies in the longevity and stability of 3 Atlas. Most comets typically fragment or lose momentum over time. However, 3 Atlas has exhibited remarkable stability, traversing the solar system without the anticipated disruptions. Such stability indicates that the object might consist of more resilient materials than the average comet, or its composition could differ fundamentally from known types. The electromagnetic properties of 3 Atlas also stand out as notably strange, adding another layer to its study. The object has emitted electromagnetic signals that diverge from the typical patterns seen in comets or other interstellar bodies. These signals raise questions because they do not conform to standard expectations for celestial objects traveling through the solar system, prompting further exploration into its interaction with solar, wind, and cosmic radiation encountered during its journey. Unlike the usual weak or standard electromagnetic radiation associated with volatile materials in outgassing comets, 3 Atlas has been noted to emit signals that are more complex and cannot be easily classified. Some researchers speculate that these signals may offer vital insights into how 3 Atlas interacts with its surroundings, especially with regard to solar winds and cosmic forces faced during its solar system traversal. The precise nature of these signals remains ambiguous, and their analysis could deliver new understanding into the object's content and behavior amid the harsh environment of interstellar space. Could these electromagnetic emissions suggest a unique structure or composition within the object that engages with cosmic forces in ways beyond our current comprehension? This ongoing mystery continues to fascinate researchers as they endeavor to decipher the signals and unravel their meanings. The surface features of 3 Atlas complicate our comprehension further. Unlike the smooth icy exteriors typical of comets, 3 Atlas displays unusual textures and patterns on its surface. This observation hints at a body that may not merely be a simple conglomeration of rock or ice, but could reflect more complex formation influenced by forces we have yet to grasp. Persistent irregularities in its rotation contribute to the mystery as well. The object has shown fluctuations in its rotation speed not common to most comets or asteroids, suggesting the potential for an internal structure or a force acting upon it that complicates our knowledge of its physical characteristics. Lastly, the chemical composition of 3 Atlas has revealed elements or compounds that are not usually found in other comets. This unique makeup adds to the overall mystique, hinting that the object may consist of materials seldom encountered within the solar system. In conclusion, 3 Atlas presents a cosmic enigma that challenges and reshapes our understanding of interstellar objects. Its behaviors have contradicted scientific anticipations, provoking more questions than answers. As this interstellar visitor continues its voyage through our solar system, it is likely to unveil additional surprises, enhancing our comprehension of universal mysteries. The study of 3 Atlas will remain a critical endeavor in contemporary astronomy, pushing the boundaries of our knowledge and compelling us to rethink the very essence of the cosmos. Whether 3 Atlas is a naturally occurring object or something profoundly extraordinary, its influence on space exploration and celestial understanding is irrefutably revolutionary.